Chapter 10 introduces stoichiometry. Chapter 10, Section 1 says that stoichiometry is the mass and amount relationships between reactants and products. So basically, we are going to be using this to convert between mass and moles of different substances. So we're going to be converting grams and moles, and then also from one type of mole to another type of mole. So the first thing that we always have to do is make sure that we have a balanced equation. This is just a little reminder. We've already done these ones before in Chapter 8. And this one asks us to convert 3.5 grams of sodium hydroxide into moles. So we start our calculation with what is known, that's our given, our 3.5 grams of sodium hydroxide. We need to add up the molar mass for sodium, oxygen, and hydrogen, which gives us 40 grams per mole. And then this is the work that we would show. So 3.5 grams times 1 mole over 40 grams. And that will allow our grams units to cancel and tell us how many moles of sodium hydroxide we could have. We can also do the opposite direction. This one asks how many grams are in 6.4 moles of oxygen. So we start our problem with the 6.4 moles of O2, and we need to use the molar mass to convert it into grams. So 2 oxygens is 32 grams over 1 mole. Mole units will cancel, and we have how many grams of oxygen that we need. This next one we've also done. This is a little reminder of how we switch from one type of substance to another one. So this is one that says if we have 2 moles of nitrogen reacting with sufficient hydrogen, so that just means that we have more than enough of this. They could have also said excess hydrogen. It says how many moles of NH3 could be produced. Okay, so we need to make sure we have a balanced equation, which we do here by adding some coefficients, and then we're going to take our 2 moles of nitrogen and our mole ratio between the nitrogen and the ammonia and figure out how many moles of the ammonia we could make. So here was our given, the 2 moles of nitrogen from the problem. This was our ratio, our coefficients from the balanced equation, and we want the moles of nitrogen on the bottom and the moles of the ammonia on the top so that the nitrogen moles will cancel, and we can see that if we've got 2 moles of nitrogen, well then we can produce 4 moles of ammonia. So this table just kind of sums up all the conversions that we're going to be doing. This is one of the largest problems. It's called a mass-to-mass stoichiometry problem, meaning that we start with mass of one substance and we convert to mass of another substance. Now to do that, it takes a couple steps. First, we have to convert into moles of the first substance, and we do that using the molar mass from the periodic table. The second thing we would have to do is go from moles of one thing to moles of the other substance. So to do that, we take our mole ratio, which is our coefficients from our balanced equation. And then the last part would be to take the moles of that second substance and convert it into grams, again using molar mass from the periodic table. So it's only combining molar masses and mole ratios. Those are our only 2 conversion factors we're using. The problems might also end up being a mass to moles problem or a moles to mass problem. So those would be just smaller versions of this entire mass to mass problem. You're just going to have to be careful when you read them as to what the question's actually asking for. So here's an example of a mass to mass problem. It says how many grams of water are produced when 13 grams of oxygen combine with sufficient hydrogen. So sufficient hydrogen, again, we can ignore hydrogen now because we know it's got more than enough of it. So we're starting with 13 grams of oxygen and trying to find out how many grams of water we can make from that. So first, make sure that we have the balanced chemical equation. That's going to allow us to have the correct mole ratio. Then we're going to start our calculation. So the numbers that we need are our mole ratio, which we already mentioned, the 1 moles of oxygen and 2 moles of water. That's straight from our balanced equation. And then we're also going to need the molar masses of the oxygen and the water, which are 32 grams per mole for oxygen and 18.02 grams per mole for water. And those come straight from the periodic table. So this would be the calculation that you would show me, all in one step. So we started with 13 grams of oxygen. That's what the problem gave us. We used the molar mass of oxygen to convert it into moles. We then use the mole ratio to cancel out our moles of oxygen and convert into moles of water. And then the last step would be to convert into grams of water. So this is the molar mass of water. So the moles units will cancel and you're left with how many grams of water you could make. And the key to these is to make sure that you do it all in one step. Don't do one part and stop and round your answer and do another part and stop and round your answer. You want to enter it all at one time and only round once at the end. The last type of problem that you might use with this is involving density. So sometimes you might be given liters or milliliters, some sort of volume unit, and have to find grams. Or it could be the opposite. You might have grams and be asked to solve for the problem in liters or milliliters. If that's the case, then you need to use density, which if you recall is mass divided by volume. So the units are usually grams per milliliter or grams per liter. So in this problem, it says to calculate the mass of lithium hydroxide used to obtain 1,500 milliliters of water. And then it tells you a little hint here that water's density is 1 gram per milliliter. Now that's one that you will need to remember. So water's is 1 gram per milliliter. If it's any other substance, I will make sure that I give you that value in the calculation. They already have the balanced chemical equation here, and the only ones that we need to pay attention to are the lithium hydroxide and the water. Okay, it doesn't say anything else in the problem about the carbon dioxide or the lithium carbonate, so we can just essentially cross those off. So now we need to start our calculation with the known, which is the 1,500 milliliters, and we're going to use the density to get it into grams, so we can do a mass-to-mass problem. So the density of water is just 1 gram over 1 milliliter. So our milliliter units will cancel, and that'll allow us to have our answer in grams. And then this last part is just a continuation. This is just our mass-to-mass problem now. And I did it all in one step so that I would only round once. So I already converted from milliliters to grams using the density. Then I used the molar mass of water to convert it into moles, the mole ratio to convert it into moles of lithium hydroxide, and then the molar mass of lithium hydroxide to get it into grams. If the problem asks you for the answer in milliliters or liters, then you would use the density at the end. So when given milliliters or liters, you begin with density. If you want the answer in those units, then you need to use the density at the end of the problem.